Yes, I'm Hans Olsson, and I will talk about Modelica 3.6, and I will specifically talk about the changes in Modelica Language 3.6, the benefits and implementation, and the share of Modelica Association Project language, and I'm working on implementing Modelica and other things in Daimler. So first, let's consider what is the goal of this. It's to promote the changes introduced in Modelica 3.6. So the idea here is that the user will get benefits of using Modelica 3.6 instead of an earlier version, so we want to upgrade. And the implementation insights is both how we want it implemented as a user and also how some hints for other implementers on how to do it. So put Modelica 3.6 in perspective. Modelica language is developed by the Modelica Association Project language. It's collaboratively developed using LaTeX on GitHub. And the plan is for regular releases, and all the major things are in Modelica change proposals. And you see here, after we switched to this collaborative work, we released 3.5 and then we released 3.6 sort of on schedule. And in Modelica 3.6, the main things were undefined modification and parameter handling in general, and also refined precedence for start values. And then we had the selective model extension, which is a main thing, and slightly improved connection restrictions. And we also changed added multilingual support so that you can translate your library into French or German. And there were 100 plus minor issues as well. So let's consider the first thing, clearer parameter handling. If you look at this model M here, there are a number of issues. We see that K is simply parameter with value 1, that's simple. But if we wanted to remove that value, how would we do? And that is where undefined modification comes in. We just set it equal to break, and then it is as we hadn't given it the value. And the second is the default for the other parameters. They don't have a value, but they have, in some cases, it might be good to have some value for testing, and in case people don't want to set anything, we should have some sort of default. And in Modelica 3.5, it was clear that P had a default 1, and that's kept. For M, it was unclear, was it 0 or not? And for N, it was also unclear, and if 0 was used, it was clearly bad, because you would get a negative size array, and it would be less than the min value. So that was improved. And let's first see what is the use of this undefined modification. The first is, as previously, you have a parameter that has a bad default and there's no obvious right value. The capacitance, it shouldn't be 1, but what should it be? So you set it equal to break. And the second similar one is when it should be computed from an initial equation. So it shouldn't have a value, and you should use fixed equals to false to indicate that it should be computed from an initial equation. And you can also use break to remove start attributes, min attributes, unit attributes, etc. So then we have a clear parameter handling, the implementation of it. The first, for undefined modification, is that we treat break in the same way as any other modifier. So we merge it and we can have final on it, as though it were just a normal one. The only difference is that if it remains at the end, we treat it as though there was no value. And in the menu, we explain it as no value and don't use break or undefined modification. For backwards compatibility, there was a new keyword break, but it was introduced already in Modelica 2.1, and it breaks in 4 loops. So there's no risk of mixing them, and we supported the old components for 11 years in Daimler. I don't know exactly how long in other tools, but the goal is to have 10 years working of models. And during that time, we prevented you from creating new components with his name. And then for consistent with min and max, that required that we removed start with a 0 from the definition of real. And it was already implemented in Daimler. But the nice thing is that it's now consistent and portable, and we have a name for it, fallback value, so that people can refer to this. And this was for clear parameter handling, and then we have also improved precedence for start values. First, why do we have precedence for start values? The reason is that we have lots of start values in the model. They can be grouped together, and in each group you should select one start value. And it's tedious to get it right, but please, there are diagnostics, and try to look at them and see if they're correct. And having both all these start values and the priority system would overwhelm users. So the idea with the priority is that the setting you do, they take effect. So the old thing was that there's a start value level that gives priority for them. And the new is that parameter propagation for start values is also considered. And in terms of the implementation, the first thing is that you have more detailed logging now in Daimler. So you can see the level in the log. And additionally, you can see which states were not selected to have start values, because that's quite often the most important thing for a state, is not to see which states have the start values, but if there is one state that does not use the start value. And the new setting can be disabled in tools like in Daimler, because there have been some models that had very bad start values, and that with new logic would be selected. And then there's a special case for PID controller in the Modelica standard library, which is not in the paper. I will get back to that later. So let's take a look at one example. This is a small model, and here you see this about groups of variables. Here are the beginning of 3 groups of variables with different start values. And this is just for iteration variables, so it's not the states even. And you see that there are lots of possible start values in the groups, and one is selected depending on this priority. And then we try to see the more use case where it matters. And one problem here is that we have to use user models, because all the examples in the Modelica standard library, they have fixed start values, so there is no ambiguity. So here we have modified a simple model with controller from the MSL, and we instead of the changes that we initialize the output of this PID controller, and we use a non-fixed start value for this inertia. And then you get the diagnostics here. And here you see that the first thing is that it gives the priority for the different selected ones, and it selects the inertia and the spring. And you also see that 2 things. One is that it includes which states were not selected. And this is the state in the PID controller, because you initialize the output. And you also see that it's down prioritized due to inactive initial equations, because there was an initial equation for this state, but it was not selected because of selective output. And that's something that should be corrected in the MSL. So now we have clear precedent to start values, and now we go on to selective model extension. This is something completely different, and the idea here is we wanted to improve how you build models. And the previous idea here, if you take this model and want to improve it in a bit, you consider here that you wanted to add a new radiator in addition to the existing one. So what you would do previously is you find this example, and then you copy it. So make it copy, and yeah, here you have a copy, and then you delete the components and connections you need to be deleted, because you need to, and then you add a new radiator and connect it. The disadvantages with this normal working procedure is you lose all traceability. So you get a new model, you don't know where it was from, and you don't know what was changed, and if both of the models are changed, it's even harder, and that's even with version control and everything. And then you have, if the original model was improved, the new model will not be improved. So that's the downside. So with selective model extension, you can start the same way, find an example of what you want to use, But then instead of copying it, you extend from it. And then instead of deleting the component, and possibly connections, you deselect them instead. And then you add the new and connect as before. So here you get the traceability. You keep the link to the original model. All the deselections are visible, so you can know exactly what you deselected. And if the original model is improved, all the changes are inherited. So now let's see the details of this. Well, it's using the same keyword break as for undefined modification, and you just break a connect or break a component, and then it's removed. And the original use case for this was to handle unforeseen structural variation. So you hadn't intended to do this. If you had intended, you could have used replace or redeclare, but now if you didn't plan ahead, you can use select the model extension to handle it anyway. The second is to have, you can have model variants like here, and especially for the synchronous things where you want to have filtering and sampling, you can it's convenient to keep the model and add those things. And then we have extended, well, while implementing, we have seen that there are additional use cases. One is that it's possible to foresee that there are variations. It's just too many, so you can't really support for more. And that's especially true for generated model, like fluid, electrical, and mechanical, because you just want to have a simple overview of what has happened, but still want to add control system and other things that are not part of the original mechanical or electrical model. And now for the implementation, there are some important things. The first is double deselection. So now you take this simple example again, and you think that you remove this connection here, and then you say that I wanted to remove the component as well. As currently specified, that's illegal, because now you have comp1 is both, the connection in comp1 is both removed as part of the connect and removed due to removing comp1. And Damula GUI automatically removes that. So it says that there is a double deselection, just remove it from the deselection. And then in terms of implementation, it's specified in this way that you first build the new model, and then you, when deselected, you remove the things that you want to remove. And that's very good, because you can see that you actually had something to remove, and that's sort of how you want to have it implemented. However, there's also a different possibility, and that is that you just propagate which components you want connections want deselected and exclude them. And that's also something that can be useful, especially for if you want to draw it immediately. So you don't want to build an intermediate graphical representation, you just want to draw, and then it's more convenient to just have a list of things that you want to be excluded from a drawing. And it also allows you to get an overview of all the components, even with deselected ones, which is useful if you want to undo a deselection graphically. Well, and then there was another thing discovered during implementation, and that is automatic sizing of connector arrays. And that will require a new slide. So go back to the previous example. There was one thing that wasn't mentioned here, and that is this connection to the tank, this red line here to the tank is an automatic sizing. Oh, the tank has an automatic sizing of its connector on the bottom. And that means that every time you connect to it, you add a new element of array. So you connect to a separate element because you don't want to mix outside of the tank. And now suddenly when you do select model extension, you are not only adding to the last element, you are suddenly deselecting something in the middle. And if you do that in Damula, you get a warning when deselecting that it involves automatic sizing of character arrays, and that there are holes in the array. So now you see that what happened was that we introduced this break, and we didn't change the size of the array. It's still 2 elements. One of them is unconnected, and then we add the new radiator and connect it again, and then it reconnects to the missing point. And the reason for that is that that's what really wanted. You didn't remove a connection in order to remove a connection itself. It was just you wanted to replace it with something else, and that's what's done here. So now this was for the selective model extension, and now for connections and other things. And the connection restriction change is the old issue here is that we have rotational models, and you want to have an optional grounding of them, so that if your gearbox isn't connected with, as default, connected to a mounting that is still. And the first version of that in the MSL used cardinality, and that's not something that is nice, and we don't want to have it. So the next thing was then that we introduced a conditional ground connector. So you enable on a flag, and if you enable it, you connect it to ground, or you connect it to something else that is slightly rotating or whatever. The problem then is that if you enable it but forget to connect to it, and then we in Modelica 3.4 had this semantic that if you enable it, you must connect to it. Unfortunately, we didn't test that semantics, and so we thought it sounded good, so we added it without really thinking it through. And then we realized that there were models, like in the machines library, that had one parameter controlling multiple things. Here, whether it's an Y or a D connection, and if it has a Y thing, you can connect to the middle point as well, but you don't have to. So here's an optional enabled connector that you don't have to connect to. So we realized that it was better to handle this by having an annotation. So if this annotation exists, you have to connect to it if it's enabled. And that means that we can also handle cases where it's not conditional, but you still want to require connection to it. So why would this fail? Well, one thing is that we really be better about this test implement all changes, and not only test implement, but test on relevant libraries. However, the new thing now can be introduced in Modelica standard library, and it gives additional benefits. Well, one thing is that the non-conditional ones, we can reduce cardinality, use of cardinality, and we also have generalized it so you can say that you can only connect once, not more than once. However, if you want to say that you can only connect it once and you must connect to it, it might be that you should have a one-to-one connection by using input-output instead. And now for the final thing, and that's multilingual support. So tools can already be translated. If you look on a thing you probably can't read, it's the Japanese version of Daimler running there. And you see lots of things can be translated there. However, many things are in the library and require something else. So that was added in the language in Modelica 3.6. And there are tools supporting it. So there was a test implementation in Simulation X. I don't know how full it is. And then we have a partial implementation in Daimler 2024X. However, and that means that all the things in blue, circle in blue here, can be translated as well. And all the things in red are all a part of the GUI and will be translated. However, translating libraries, that's a big thing. So don't expect that automatically. So, conclusion, Modelica language is progressing. It's gradual because compatibility matters and we want everything to be implemented. So we need input, both in terms of ideas and in terms of priority. So there will be a Q&A session on Thursday morning, and we can also send in questions late and inputs later to our mailing list or contact me directly. And all the new ideas then have to be designed, implemented, tested, and found. So, thank you.